Hello. So this section is 1.3 that we're going to go over next, and it's slopes, y-intercept, graphs. So first we'll look at slopes. The formula for slopes is y2 minus y1 over x2 minus x1. And you're given points x1, y1, x2, y2. So then we subtract the y's and subtract the x's. But they do need to be in the same order. So if whichever point goes first on top, the same point goes first on the bottom. There we go. So if you look at the first one, when we're finding the slope, and usually the letter used for slope is m, you take 5 minus 3 over -1 minus a -2. 5 minus 3 is 2. And then these two negatives make a positive, so -1 plus 2 is 1. And 2 over 1 is, so our slope is 2. Try the next one. Subtract the y's, -3 minus a -2 over 1 minus a -6. And again, the two negatives make this a positive. -3 plus 2 is a -1. And on the bottom, this makes it a positive, so we have a -1/7. When the slope is positive, that means this line is increasing from left to right. A negative slope means it's decreasing from left to right. Find the next one. So we take 3 minus 5 over 2 minus 2. And 3 minus 5 is a -2 over 0. But we know we cannot divide by 0. So this one, it's not called doesn't exist, it's undefined. A slope that is undefined is a vertical line. It goes up and down. And notice it's not a function. But it does go up and down, and the equation does not have a y in it. It's only x. In this case, because the 2 is repeating, it would be x equals. So x is always 2, and the y value can be any number. The last one, 1 minus 1 over 3 minus 0. 1 minus 1 is 0, and 3 minus 0 is 3. Well, we can have 0 in the numerator, so 0 divided by 3 is just 0. But it is a special graph. This one is a horizontal line. And its equation doesn't have an x in it. It's y equals a number. And notice the y value that's repeating is a 1. So in this case, it would be y equals 1. So those last two are special cases, and they will pop up. Y equals negative 3x minus 1. We want to graph it using the slope and y-intercept. Well, the way we know it's linear first, we know it's linear because the x and the y are both to the first power, and they're not in the denominator. So as long as x and y are to the first power and not in the denominator, it is linear. Now, to graph using the slope and the y-intercept, you want it in y equals mx plus b form, which it is. But m is your slope, as I said earlier. Slope. And b is the y-intercept. And you can write it as a point, 0, b, depending on what it's asking for. So our slope is negative 3, and our y-intercept is negative 1. When we go to graph it, we don't need this, I already did this. Okay. Now when you go to graph, the first thing you want to do, well, is draw your graph. First thing you do is mark your y-intercept. Remember, that can be written as a point 0, negative 1. So that would be here. Then we use our slope. But when you go to graph with the slope, you need a fraction. So if it's a whole number, you can place it over 1. So then you do rise over run. So that means rise up and down. In this case, a negative, we'd go down 3 and over a positive 1. But you do that from your y-intercept. So we go down 3 and over 1, and then we draw our line. Let's try one more. What if we have 2y plus 3x minus x equals 4. Okay. Now if we wanted to graph this using the slope and y-intercept, we need to get it in y equals mx plus b form. So that means you need to be able to solve it for y. So we need to get y by itself. The first thing we would want to do then is move the x so 2y's by itself. So we need to add the x to the other side, because you always do the opposite. So we're going to add this x to the other side. Since it's a minus here, it becomes a plus here. The next thing we need to do is divide by the 2, because we want y by itself. Notice there's 3 terms, so you divide each term by 2. The first one, the 2's cancel and leave y equals. And then remember, when there's no number, it's a 1. So that's 1/2 x. And then 4 divided by 2 is 2. So then we can graph it. Okay. So first thing, our slope is 1/2. Remember, that's rise over run. And our y-intercept is the point 0, 2, which is where we start. So we started our y-intercept, and we'll assume these are all 1 unit. This is 0. We go up 2. So that's the y-intercept. Now my slope is 1/2, so I go up 1 and over 2. So from here I go up 1 and over 2, and I'm here. And there's my line. Notice that this one was positive, and it went up. This one was negative, the slope, and it went down. So a positive slope increases, a negative slope decreases. Another way we can graph is with the intercepts. And when you're graphing with the intercept, if you want to find the x-intercept, that's when y is 0. So you just plug in 0 and solve. Now another way you could do this, let me show you something first. Usually when you're finding x and y's intercept is when x and y are both on the same side. So if I bring this 12 over, it becomes a minus 12. And then I'm going to bring, so I move the 12 that way. Now I'm going to bring the 4y this way, so that I have 3x minus 4y equals a negative 12. So I subtracted the 12 to the one side, and then I'm bringing, and you'll see why in a minute, it makes finding x and y intercepts much easier. And I brought the 4y over here. So now when I want to find x-intercept, that's when y is 0. Now if y is going to be 0, this drops out, divide by 3, and get x equals, so if that drops out, we have 3x equals a negative 12. Divide by 3, x equals a negative 4. The y-intercept is when x is 0. If we look at this equation, if x is 0, this drops out. So then we have negative 4y equals a negative 12, because this dropped out. So you could actually just do this and then in your head divide by the negative 4. Negative positive 3. So then when you graph it, we know the x-intercept's negative 4. 1, 2, 3, 4. And the y-intercept is 1, 2, 3. And then you just draw your line. It's just another way of solving it. Try one more. If we had 2x plus 5y equals 20. So you want to find the x and y intercept and then graph it. the x-intercept, y is 0. If y is 0, then that drops out. Notice if we divide both sides by 2, we have 10. So we have 2x equals 20, divide by 2, x is 10. So you can do that in your head. For y. And if it's a fraction, then it's a fraction. The y-intercept, you let x be 0. That would drop out then, because x is going to be 0. Divide both sides by 5. 20 divided by 5 is 4. So y is 4. Then you would just graph it. 2, 4, 6, 8, 10. So our x-intercept is 10. And then 2, 4, our y-intercept is 4. And we draw our line. So it's just another way of drawing. You could solve for y and also do it, but this is nice because some of the stuff in business, we need to know where it hits the x and the y axis. So a lot of times we will find the intercepts. F of x is the yearly sales of Nintendo games in billions of dollars as a function of time in years since 2000. So this is since the year 2000. Find the slope and the rate of change. They're the same thing. Slope and rate of change is just another way of saying it, because it's telling you how it's changing. But our slope, remember y equals mx plus b, if we look at the equation, f of t equals 3.5 t I think it's a plus 12.5. We're not plugging values in, so it doesn't matter. But remember, it's y equals mx plus b. And y is the same as f of x. So our slope is the 3.5. Rate of change is 3.5. And then it's y value over x value, because rise over one run. And remember, the slope is the change in y over change in x. Now our y value was billions of dollars, and t was years. So it's increasing at $3.5 billion per year. So it's 3.5 billion each year. That would be over 1, so 1 year. The last one is monthly cost to manufacture tennis balls. C of x equals 4,000 plus 0.5x, where x is the number of tennis balls produced each month. So think about the slope. What would the slope be? Okay. If we look at this equation, it's in a little bit different order. The slope is always with the x, so the slope is the 0.5 or 1/2. Marginal cost is rate of change. It's slope, when we're linear anyways. It's how it's changing, and in this case, because it's a straight line, it's changing by its slope. What is the cost for each additional tennis ball in a month? Well, what this is telling you, the slope, it's our change in y over our change in x. Our y is cost, and our x is tennis balls. So the cost goes up 50 cents for each tennis ball. So the price goes up 10 for each tennis ball. I thought I had one more problem, but that looks like it. Okay, I'll leave this open in case you need that. But so it's cost and tennis ball, rise over run, change in y over change in x. So think about what your y is and what your x is and write this each time, and then you can explain what it means. Thank you.